different chapters according to the product group. We will talk about wetting and dispersing additives, about defoamers, and about surface additives. And last but not least, we will have a closer look into rheology modifier. Each chapter will give you an insight into challenges we have faced in different systems, as well as some additive recommendations. When we talk about 2-pack coatings, we differentiate between 3 main systems. So the 3 major types of systems are the 2-pack epoxy systems, the topic of yesterday's sessions together with Adil. There are polyaspartic systems, a very special type of 2-pack systems we will not focus on today. And we have the normal or typical polyurethane systems today with a focus on high solid as well as solvent free. Why are there different types or chemistries on the market? The different types are needed since all of them give different properties in terms of mechanical resistance, such as hardness or flexibility. They have different curing times, and also the chemical resistance can be different, and therefore the different 2-pack systems are used for different applications. When we talk about these systems, we have some main raw materials. One hand side, we have the binder, the polyol binder. We do need OH functionality. We can have polyester polyols or polyether polyols or even acrylate ones. Then, of course, we need the second component, the hardener, often mentioned as component B. Here we differentiate between aromatic or aliphatic isocyanate hardeners. And later on in this presentation, we will also see what is the main difference between these types of hardeners and what can be a challenge when using the different ones. And we also have moisture scavengers. And when we talk about pigmented system, we also have, of course, pigments, we have solvents and all other raw materials which are available for these systems. Why do we need high solid systems or solvent-free systems? In more and more applications, there are coming regulations which are dealing with VOC or emission or other important properties. When we are talking about reduction of VOC, there are coming directly high solid systems or solvent-free systems in mind. There is, for example, the AGBB or the Blue Angel regulation. Depending on regulation, there are different restrictions regarding SVOC or VOC or other components required. Here at BÜK, for example, we are able emission chamber measurements to get the AGBB conformity. So it was done for one of our products, for example, Disperbec 2152. And also VOC measurements belong to our daily business. In general, we try to meet or to cover all regulations globally. What is for us the definition of high solid or solvent-free systems or formulations? In general, we say there are different ways to reduce the VOC. It can be a change of the coatings technology. You can achieve it when you destroy the VOC, or you can reformulate your solvent blend. But today we will concentrate on discussing the change of coatings technology. There are, for example, powder coatings. Powder coatings do not have any VOC, but there are some challenges. For example, when we apply the powder coatings, we will get in troubles when we want to apply uneven or large parts. We need other equipment. That means we have some investment to do. And not in all cases, the leveling is sufficient. Another possibility would be UV curing or electrobeam curing systems. Also here, we are facing challenges. We have uneven or large parts, which are not easy to apply. Also here, we cannot use our normal equipment, means also here we have to invest in equipment, and we can face some adhesion problems. Another possibility could be to change to waterborne systems. When we talk about waterborne systems, we can have problems with early water resistance. When we do forced drying, we may observe some popping. We have different drying time in comparison to solvent-borne systems. It is strongly dependent on humidity. We can face foam as well as some challenges in terms of substrate wetting. Another change in coatings technology can be to change to high solid systems and to solvent-free systems. When we talk in general industrial coatings about high solid systems, there's always a connection with spray application. Here in that case with airless application or air mix. We have high pressure and small nozzle size, and that brings some challenges with us. When we talk about solvent-free systems, we mainly talk about self-leveling systems, for example, about floor coatings. When formulating two-pack systems, we can face different challenges during production of the paint or during application. We may see some air entrapment, pinholes, or foam formation. We have to achieve a good viscosity reduction in filled and non-filled systems. We can have some sedimentation when there are pigments or fillers included in the formulation, and we also have to adjust the flow and leveling. And with this presentation, we try to find now a solution for all these problems. Let's start with wetting and dispersing additives for pigmented systems. I would like to start with a two-pack top coat. This top coat was applied with airless application on steel panels. The dry film thickness was around 50 microns. And here on this page, you see now two panels. Left-hand side, the top coat was without wetting and dispersing additive. And right-hand side, it was the same top coat, but here in that case with wetting and dispersing additive. In the middle, this here is a reflection of the light. The image of the reflection of the light on the panel, which is right-hand side, is much sharper as compared to that one on the left-hand side. So the use of a wetting and dispersing additive for high solid systems is of prime importance when you want to achieve good results. What do we have to consider when we want to select the right product? Of course, we have to think about the application of the type of the coating. Do we talk about a primer, a base coat, or a top coat? Do we need a controlled flocculating wetting and dispersing additive or a deflocculating one? And do we have some problems regarding temperature stability? May we face some yellowing or UV stability? Do we need something regarding food contact compliance? We also have to think about the system, about the polarity. Do we talk about low polar systems, medium polar systems, or high polar systems? About the resin chemistry or reactivity. And when we are not talking about clear coats, but about pigmented systems, we have to think about the pigmentation. Do we have mainly organic pigments or inorganic pigments? What kind of surface do we have on our pigments? And what is the surface area? Is it a small particle size pigment or a higher particle size pigment? Also important for the selection of the right wetting and dispersing additive is the processing. The grinding method, for example. Do we talk about a co-grind or a single grind, or even pigment concentrates? Do we have resin-containing or resin-free pigment concentrates? Do we talk about self-leveling or about roller application or about spray application? That all has to be considered when we want to choose the right wetting and dispersing additive. Another important point is a commercial point or the compliance. Do we have to meet a cost-performance ratio? Do we need certain regulations like REACH, AGBB or other ones? In terms of environmental aspects do we need to talk about VOC? That all is very important when we think about the right choice of wetting and dispersing additive. Here on this slide, you see a few examples of our product portfolio. Here on this axis, there's listed the polarity of the resin system. We're starting with non-polar, for example, with long oil alkyds, going to air drying alkyds, TPA, polyester melamine, acrylate melamine, or for us today important, the 2-PEC PU, even more polar NC or 2-PEC epoxy. When you want to find the right additive for your 2KPU system, you can work with all these products which are good for 2-PEC PU systems. Here, the Disperbic 110, for example, or 180 for mainly inorganic ones. The Disperbic 2155, you see it is very broadly compatible in a wide range of resin systems, or one of the 160 family, or the solid one, the Disperbic 2205. That helps you for the right choice. Coming now to one application example. Especially for high solid systems, we did a lot of lab trials. It is always our target to have for all kinds of systems the perfect additive solution. Here in this case, we developed a starting point formulation based on a hydroxy acrylic resin with 75% non-volatile matter. It was the target to achieve a light grade co-grinding formulation. And in our screening, we tested a lot of our wetting and dispersing additives. And finally, we found that Disperbic 2150 gave the best delta E value. Here in that case, it was a pour out on PE foil. We did a pour out, did some flash off, and then we rubbed this upper area. And you see more or less no difference. We have a delta E of 0.48. Left-hand side, there was the same coating without wetting and dispersing additive. What you see very clearly in this rubbed area that you have a high delta E value, about 2.99. So for this kind of system, the Disperbic 2150 gave the best results, delta E, millibase viscosity reduction, as well as the storage stability. Besides stabilization of pigments, also the stabilization of fillers can be important. Here we took the example of a solvent-free coating in calcium carbonate in the polyol component. Fillers are needed to achieve good mechanical properties, and to get this, often large amounts of fillers are needed. As well as with pigments, it is very important to have well-wetted and stabilized fillers. Otherwise, we are facing problems like higher viscosity, so that the filled component can't be mixed properly with our second component, the isocyanate component. Or we have a non-sufficient leveling of the coatings or flow coating. In the chart right-hand side, you can see the differences in viscosity. Here, there was a calcium carbonate in the polyester polyol component without wetting and dispersing additive. It has a by far higher viscosity as compared to the concentrate with wetting and dispersing additive BUC W969. You see that the viscosity is less than half. The market is always asking for higher filler loading with the same processability or workability. Normal is around 40 to 60%, but in some cases, even higher than 70% is required. And so we definitely need a wetting and dispersing additive in order to handle this calcium carbonate. Besides the very typical fillers for coatings, there are also some specialists who needs to be wetted properly. Here in this example, we have the APP or ammonium polyphosphate. This is used, for example, as flame retardant and much more difficult to wet or stabilize than calcium carbonate. Therefore, a more efficient wetting and dispersing additive is needed. Here in that case, it was done with the BUC 9T76. You can see very easily that you achieve a lower viscosity with using book 1976, as compared to the control, which is here left-hand side. Also here, it was a focus on the processability, which was to achieve with 1976 in a higher filler load. Coming from easy to disperse fillers via more difficult ones to the pigments, which needs to be stabilized in solvent-free systems. Also here, it was done with the book 1976. It is a very versatile wetting and dispersing additive. It can be used in high solid systems as well as in solvent-free systems. Here we see the example of pigment concentrates in castor oil, also based on 1976. We used, depending on the pigment, different pigment loads. And you see again here, right-hand side, that the examples with wetting and dispersing additives show better results. Here it is not shown the viscosity, but the delta E value. The rub-up test was done in a white reduction with Kronos 2190. And when we are not using a wetting and dispersing additive, you see very high delta E values. With wetting and dispersing additive, you see that the column is very low. So that means we definitely need wetting and dispersing additives. After the seminar, you will get the presentation, and in the appendix, you will get the formulation of these pigment concentrates. Summarized for 1976 can be said, it is a hyperbranched polyamine. It is a deflocculating wetting and dispersing additive. You see it here, it has a spherical structure. We have a high density of pigment affinity groups. So it means it is able to cover a high surface of pigment. We can stabilize inorganic, organic pigments with this, but even for carbon blacks and fine particle-sized carbon blacks, it is a perfect choice. And since it is a 100% product, it can be used in solvent-borne and in solvent-free systems. Besides the deflocculating wetting and dispersing additives, there are also controlled flocculating additives available in our product portfolio. With these additives, the focus is not on viscosity reduction, but on storage stability or on anti-settling. Here we have again the example of calcium carbonate. You see it here in this picture, the two bottles. Left-hand side, there isn't used a wetting and dispersing additive. And right-hand side, there was used the Antiterra 200. And you see that left-hand side, you have a strong sedimentation or anti-settling, and right-hand side, you do not see any sedimentation, maybe a slight syneresis, but it will be easy to stir up. Also here, what you see is we have two glass jars, left-hand side again with without wetting and dispersing additive. And you see that the particles are totally settled down. With using a controlled flocculating wetting and dispersing additive, you see that over a certain time, still the particles are well distributed into the paint or in the coating matrix. So that means our controlled flocculating wetting and dispersing additives, such as Antiterra 200 or P105, brings the dispersed particles into a loose structure, which leads to even higher viscosity and good anti-settling properties. How does it work? So controlled flocculating wetting and dispersing additives, they have pigment affinity groups. They're going on the surface of the pigment, of course, but they're also able to build a network with hydrogen bondings so that you get this higher viscosity. We can say that they are mainly used for inorganic pigments or for fillers. And we recommend to use it whenever the focus is more on protection than on perfect appearance. They can be used to control flocculating additive. For example, in primers, because these additives may have a negative influence on the gloss due to this network formation. But due to this network formation, they can lead to a higher film build, which is important, for example, for primers. Another positive impact of these additives is the positive impact on anti-corrosion. We are back again to our deflocculating, wetting and dispersing additives. In a lot of cases, we do have aminic pigment affinity groups. These pigment affinity groups should normally adopt to the surface of the pigment, but if they are free, they are also able to react with some components of our system, of our 2KPU system. What we want is that our pigment affinity group goes with our interaction acid-base to the acidic pigmented surface treatment of our pigment. So in most cases, when we talk about organic pigments, we have an acidic pretreatment. And due to this acid-base interaction, we achieve an excellent and long-term pigment stabilization. But it also can react with a liquid matrix. So for example, when we talk about 2KPUs, we have the polyol component, so component A, and the hardener, the polyisocyanate component. And in that case, the amine is able to react or to catalyze the curing reaction, and that means it can shortening the pot life of our 2K system. And that is an undesired interaction of these wetting and dispersing additives. So therefore, we have to have a closer look what our additives are doing. So that is what I mentioned. We have the polyol component, we have our hardener, and now we want to see if the aminic groups are able to catalyze our 2K systems. And that is what we want to see in a small lab study, what we have done in our lab. In order to find out what happens in terms of pot life with different amine values of wetting and dispersing additives, we included these 4 additives in the lab study. We have the Dispabuc 2022. It is a CPT-based acrylate with an amine value of 61. We included the Dispabuc 2025. Also here we talk about CPT-based acrylate with an amine value of 37. There is a Dispabuc 2152. And here in that case, the amine value is not measurable. It is a hyperbranched polyamine and has an aminic pigment affinity block. And this block is surrounded by a hyperbranched structure. So that the aminic pigment affinity group is encapsulated and the amine value is not to determine. And we use the 2155 here as an example of our PU family, which has an amine value of 48. And also here this product, it is encapsulated. What did we test? So for this lab study, we used the standard GI system. It was based on an acrylic system, here Zetalux 1753. We took some standard solvents like PMA, xylene, Chalzol A. As a catalyst, it was used DBTL, butyl acetate, and something for leveling. We used 2 different hardeners, an aromatic hardener, as well as an aliphatic hardener. And the mixing ratio was 3:1 by weight. And we wanted to achieve a cross-linking of 120%. And now let's have a look what happened to the pot life with the different hardeners and different wetting and dispersing additives. Here are the results when we are using an aliphatic hardener. On this axis, we talk about the flow time. It was measured with the DIN 4 cup from 0 to 300, then we stopped. And here is the time. Initial, after 1 hour, 2 hours, 3 hours, and 4 hours. It was used 4% of wetting and dispersing additive, solid on resin solid, and as mentioned before, 120% curing. And now we see that here, with the different wetting and dispersing additives, the increase of pot life was more or less the same. When we go now to an aromatic hardener, and when we have a closer look to the use of an aromatic hardener, which is already more reactive than an aliphatic one, we can see clearly that with free amine or higher amine value, the pot life can be influenced. And that is what we see here. We have again the same diagram, the flow time and the pot life time in hours, 0 to 3 hours. And here we see with the Dispabook 2022 that we have a very short pot life. With the Dispabook 2025, it is also increasing very fast. And with 2155 and 2152, which have the amine value encapsulated or the amine encapsulated, we do not see a big influence. Therefore, we always say, or we recommend to check if our wetting and dispersing additives may have an influence on the pot life. Let's have a closer look to the 2155, which belongs to our polyurethane family. It is deflocculating. It has a lot of pigment affinity groups. We recommend to stabilize there with inorganic pigments, organic pigments, carbon blacks, or even effect pigments. And with the Dispabook 2155, we say that we stabilize via steric hindrance. Here in this box, you see the different product family out of our polyurethane chemistry. So there's the 160 family, the 182 family, 170 family, and as mentioned, the 2155. So what is our conclusion of this lab study? So it was done, the pot life and viscosity profile during storage of a 2-pack polyurethane. It is always better to use encapsulated wetting and dispersing additive than wetting and dispersing additive with freely accessible aminic pigment affinity groups. And we saw 2 slides before that is especially visible with aromatic isocyanates because these are more reactive than aliphatic ones. Coming now to our recommendation chart for wetting and dispersing additives. After each chapter for each product group, you will get such a product overview, what we recommend for these systems, for high solid systems, as well as solvent-free polyurethane systems. We split it into different groups. We have general recommendations, which can be used for high solid as well as for solvent systems, solvent-free systems. Here we want to highlight Book 9076. You saw it some slides before, some examples for this. We have the Dispabook 110, one of our phosphoric acid ester, especially for inorganic pigments or titanium dioxides. You saw some examples for Dispabook 2155 or 2155TF, that means tin-free. And a second recommendation is the Dispabook 2152 that was specially designed for epoxy systems. When we talk about solvent-free or additives recommendation for solvent-free systems, we would like to highlight the Book W969. You saw an application example with a calcium carbonate. We would like to highlight 3 controlled flocculating additives like Antiterra 200, Book 220S, and the Book P104S, and the Dispabook 111, which is also a recommendation for inorganic pigments in titanium dioxides. For high solid systems, we have 4 main recommendations. Dispabook 180 for inorganic pigments, Dispabook 2055 as a very versatile wetting and dispersing additive, as well as a 2150. We have also here a specialist that is the Dispabook 2205. It is one of our solid wetting and dispersing additive. It is in pellet form. You can use it in pellets or you can make a solution out of it. And as second recommendation, we have the DISPA book 163 tin-free or the DISPA book 2013. So this is our recommendation chart for wetting and dispersing additives for our 2K systems. Beside good stabilized pigments, there is also a perfect defoaming very important. Before we go to detailed product recommendations, I would like to start with some basics. How can we destroy a foam lamella? So let's see how to start the, oh yeah, it's running. As soon as you add a surfactant to your paint, they will orientate into the interface liquid air. And there are also coming air bubbles in your paint, which also orientate to the interface liquid air and come to the surface. As soon as the air bubble arrives to the surface, the lamella starts to run empty, but at a certain point, the polar parts of the surfactant come too close, and the lamella can't get thinner, and the lamella is stabilized. And then you have stabilized foam. That is the reason behind foam stabilization. That is, of course, something what we do not want to have. How can we now destroy this foam bubble? There are different ways to destroy it, different mechanisms. All these three little dots are more or less defoamers. Generally said, the defoamer has to enter the lamella and has to destroy it. The defoamer can work with de-wetting the lamella or destroying it with hydrophobic particles, or with de-wetting or spreading. It has to be said that all these three mechanisms take place at the same time. It cannot be said that only this one happens, or the destroying or the spreading happens. What does it mean for our coating? Let's start again with high solid coatings. What are the challenges in high solid systems? When we talk about high solid systems, we mainly talk about airless application. When we do airless application, we always facing a lot of foam, mainly microfoam. You see it here on this picture. When we talk about microfoam, we can say that it is always much more difficult to destroy this microfoam than the macrofoam. Here we have the example of macrofoam. This picture or this application was done with a conventional spray application, HVLP, and we are facing mainly macrofoam and only a very little microfoam. So that means when we talk about high solid and airless application, we have to consider the right defoamer. Here on this slide, you see in white high solid top coat based on Syntalat A086HS. Left-hand side without any defoamer, and right-hand side with 1% of a new development. Left-hand side, you have again the reflection of a light, and you see that you have a lot of surface defects here. Right-hand side, you see the light reflection much sharper. In that case, it means you have much less foam as compared to the control one. And that was always visible in a black 2-pack PU top coat. Left-hand side, again the control without any defoamer. And right-hand side, more or less no foam and a very sharp reflection of our light. And here we use 1% of our new development, which we will introduce soon. Generally can be said that foam or air entrapment can cause a lot of defects. You see again that the lamella is running empty, the foam bubbles are coming closer together, and they are not able to be destroyed. And then you get pictures like this. That is a microscopic picture, and like this, and you see that you have a lot of air entrapment. In comparison to the picture right-hand side, where there is used 1% of Book A535, and you do not see any foam bubbles left. We have another nice defoamer we would like to highlight here. That is a Book 088. It is an aromatic-free defoamer based on silicones and polymers. And we have here again some pictures. You have the control. It was a 100% fluor coating. Here we don't have any defoamer used, and you see a lot of big air bubbles. And below you see 1% Book 088, and there is no macrofoam left. There is still some microfoam visible, but we have to say that these samples were not produced with a vacuum dissolver, but with a normal one, so that some microfoam was incorporated. So it was a very tough production of the fluor coating. And it can be said that Book 088 can help to improve these properties by improving the deaeration during application, but also during production. When we talk about Book 1794, that is an emission and silicone-free polymeric defoamer, we can say that it is a perfect balance between defoaming efficiency and less impact on turbidity, because defoamers needs a certain incompatibility to be active. And once it is too incompatible, it can cause some turbidity, especially in clear coats. And that is what you see, for example, here. Without defoamer, you have foam. That was a PE foil, and in the background you see some trees. And right-hand side, there's also a foil with a clear coat and 0.2% Book 1794, and you do not see any foam bubbles, and there is no turbidity. And here we have some microscopic pictures. Without defoamer, you have big air bubbles. We have one of our competitors with a lot of microfoam. And right-hand side, there's the 1794, which looks perfectly. Other benefits of the 1794, it is 100% solids, emission-free as well as VOC-free. It meets some regulations like the AGBB. And it is a very effective defoamer for PU, of course, because we presented or highlighted today, but also for polyaspartics or epoxy-based systems. As I mentioned before, it has more or less no impact on turbidity, so that we can say we can also recommend it for non-pigmented systems. And also here we can mention it does not only help for the application of the final coating, it is also very effective during production or the further processing. Besides the 1794, I would like to highlight also the 1795. It's a very good defoamer for spontaneous defoaming. And here we cannot only recommend it for solvent-free coatings and high solid coatings or flow coatings, we also can recommend it for general industrial coatings, for all kinds of solvent-borne coil coatings like PVDF or polyester melamines, or even for UV systems, it can be recommended. It is silicone-free, as well as thermostable and ideal for high baking temperatures. It will not cause any yellowing, and it is emission-free. And here you can also see on this slide the foaming tendency or defoaming tendency. The higher the column, the more foam was included into the coating after application. In that case, it was macrofoam. Without defoamer, we have a lot of macrofoam. Using a polymeric one like Book 054, it was already less. BUC 088 in that case even helped more, and the 1794 gave more or less no foam at all after application and after drying. Here you see also two other examples for floor coatings, and also here you cannot see any foam bubbles left after drying. That leads us to our defoamer selection, the selection chart or recommendation chart for high solid systems and solvent-free polyurethane systems. Again, we have here in the middle the general recommendation with BUC 054, 088, 1790 or 1799. When we talk about solvent-free specialists for floor coatings, for example, we have the 1760, 1794, which I presented just before, as well as second recommendation 1795 or BUC A535. When we come to high solid specialists, we have the BUC 052N, polymeric one. We have the BUC 085, 1788, a very efficient one already in low dosages, and the BUC A530, also a very efficient one. And this selection chart will help you to select the right defoamer for your coating. So we finished already two of our product groups. We have now perfectly stabilized pigments and we don't have any foam left. Now, what we need is a perfect leveling, a superb final appearance. That can be achieved with our third product group, our surface additive. Let's have a look. At first, I would like to show you some surface defects, which is related to pigments, the Bernard cells. That is what you see left-hand side above. The gray pictures are two airless applied panels. In both cases, the pigments were perfectly stabilized. The difference between both pictures is only the silicone additive. The upper one doesn't contain any silicone additive, and the lower one does. Here you see perfect Bernard cells. Due to the fact that we reduce the surface tension of the coatings, we do not have any difference in surface tension between the pigment particles during the solvent evaporation. That is one very important point when we talk about surface additives in solvent-containing coatings. What is the most important when it comes to surface tension in coatings? Have a look at this little movie. We apply now two coatings. One coating which contains a silicone additive, a surface additive, to reduce the surface tension, and one is without any active substance, surface active substance like a silicone. And it is very obvious that the coating without silicone doesn't wet the surface properly. Why does this happen? We have to achieve that the surface tension of the coating is lower as compared to the surface tension of the substrate. That is what you see very simplified here, right-hand side. I can start it again. So we start with the surface tension of the coating is 45 millinewton per meter, and we reduce it slightly with surface active substances, and the droplet starts to spread. And once we are lower in the surface tension as compared to the substrate, the droplet wets perfectly on the substrate. And that is very important when we talk about coatings. I want to show this to you in three examples. So we have three systems. And we have one substrate. And the substrate always has a surface tension of 30 millinewton per meter. System 1, the surface tension of the coating 33 millinewton per meter. What does it mean for our final application? Since the surface tension of the substrate is lower, we have no substrate wetting. You see the stripes here, and you still see the substrate. And we have a poor flow. What do we have to do? We have to reduce the surface tension. And then we can adjust the flow and leveling with less active silicones or acrylates. Going now to system 3. This system has a surface tension of 25 millinewton per meter. Remember, the substrate has 30 millinewton per meter. We have a very good substrate wetting, but a poor flow and leveling. That means in that case it was too much. We have to increase the surface tension by reducing the amount of active silicones, and then we have to adjust the flow and leveling. Go back to system 2. Here the surface tension is only 29 millinewton per meter, so just below the surface tension of our substrate. And we have a good substrate wetting, and you see that we also have a very nice leveling. If needed, we can adjust the flow and leveling with less active silicones or acrylates. What does it mean for our coating? We need to reduce the surface tension. We can do it with 310, for example, or with BUC 333. And when we talk about viscosity reduction for the penetration improvement, we can use the BUC 9076, BUC W969, this for BUC 111 or 180. And that is what you also see here on this page. We have, on this picture, sorry, you have two steel lids with a yellow coating. And left-hand side, you see a substrate with a lower surface energy, and that means the coating de-wets and we have poor leveling. Right-hand side, we have a substrate with higher surface energy, and there we have good wetting and good leveling. So the conclusion for us is we have to reduce the surface tension so that we achieve a good substrate wetting on the lower energy substrate. And we have to keep a good leveling on a higher surface energy substrate, for example, with BUC 310. But we have to say that we can't reduce the surface tension as much as we want to do. That is what you saw 2 slides before. Since we also have to consider a good leveling beside a perfect substrate wetting. And leveling and substrate wetting are each other's opposites. The lower the surface tension, the worse the leveling, and the higher the surface tension, the better is the leveling. Have a look to the element mercury. It has a perfect surface, but an extremely high surface tension. And therefore we can say, reduce the surface tension as much as needed, but not more, in order to maintain a good level. There are also some other paint defects which are related to the surface tension. We talked about poor flow and leveling, about insufficient wetting, but we also have problems, we can have problems with the foam stabilization. We discussed it several slides before. As soon as there is a surface active substance in our coating, we have foam stabilization, and we have to consider the deformer package. The overspray acceptance will be influenced, and also the cratering tendency. And all these phenomena are related to the surface tension of our coating and also of our substrate. So what does it mean for our leveling? The main part is done by silicones. We have to reduce the surface tension, and we can adjust slightly also the flow and leveling with silicones. But we need also some acrylate, some real leveling additives, in order to achieve the last fine-tuning to achieve a very good and perfect leveling. So what can we recommend? We have BUC silicones like a BUC 306, 315 or 331. And normally we start with a dosage of 0.05 up to 0.3% delivery foam on total. Here we can say that we now have also some cyclic siloxane content reduced alternatives where the content is lower than 0.1%. Like for the 306, we have the book 3761, and for the book 331, we have the 3753. You can exchange it one by one. It will not have any influence on the final appearance. And as mentioned, for the fine-tuning, we have our acrylates, like a book 354, 361N, or book 392. Here, we recommend to start with 0.1 up to 0.5% delivery form on total. I would like to show you some examples of our newest developments. I would like to start with the book 327. 327 gives you an improved leveling, especially in 2-pack high solid formulations. Here you see two pictures of a polyaspartic. It was in that case not a normal polyurethane, it was a polyaspartic system. Two panels. Above the panel is a control, so means without leveling additive. And below we have the right leveling additive, a correct selected one, the book 327. And you see again here's a reflection of the light, and with using a silicone additive or a correct selected leveling additive, you have a much sharper light reflection as compared to the control where the leveling is not good. The book 329 is a perfect addition to our product portfolio. It combines defoaming properties with good leveling. And we can say that you only need very small quantities. And also nice is that we talk about 100% active substance. So that means it is strongly recommended to use in high solid systems or in solvent-free systems. Here we have again two pictures. We have a solvent-free self-leveling 2-pack system. Here there was not used any leveling additive. You see also here that the light reflection is not really sharp. And with using 0.1% of book 329, you see that the light reflection is much sharper. What we can say about book 329 is that the major application fields is high film build for solvent-free systems like PU, epoxy, or also here polyaspartic-based floor coatings. Coming back to 2-pack PU high solid systems, here on this slide you see different silicone additives we tested. We wanted to see in how far our silicone additives stabilize foam. Since silicones are surface active substances, that means they have the tendencies to stabilize foam. Here we did a very simple shaking test. We took component A of a polyurethane coating. We put it in a glass bottle, always the same amount. And then we incorporated 0.1 active substance of different silicone additives. Here we took book 306, 310, 333, 378, 3760, as well as buxylene 3700. We put it under a shaker for 30 seconds, and then we judged after 1 minute after shaking. And you see in the control, where no surface active substance is included, we have more or less no foam formation or stabilization. And with using different surface active substances, we have some foam formation. I would like to highlight here the book 3760, which is one of our silicone additives with the lowest impact on foam stabilization. You see here that the foam is much less as compared, for example, to the 378. That does not mean that all other additives are not good. I just want to say that you have to consider it. When you choose a defoamer, you have already had chosen your right silicone additive. At the end of the chapter of surface additives, I would like to show you our complete overview of non-reactive silicones. Here are listed all silicones we have. They are listed according to their polarity, from low polar to high polar, according to their tendency to reduce the surface tension in the coating, from small or minor impact to a strong impact on surface tension reduction. And we also can list them according to their ability to reduce the slip, or to the COF, so coefficient of friction. We have, for example, the book 322, which is very low in polarity and has only a minor impact on the surface tension reduction, like also the 320 does. Here above, we have the very strong ones, like a 378 or 306. These additives have a strong impact on the reduction of surface tension, and they also give a high slip or a low COF. What you also can see here on this slide or in this diagram is that our alternative with the low cyclic siloxane content, it is always the light blue one. So for example, we have the 306 and the cyclic reduced version is the 3761. The same, for example, here for the book 323. We have here an alternative with a low cyclic silicone compound with the book 3780. So that means you can read a lot out of this chart. But of course, it is not really helpful for your selection of silicone additive in your high solid system or in your solvent-free system. Therefore, we created again a recommendation chart. In that case, our general recommendation are book 310, 3761 or 3764. And as a combination partner for the final appearance, we have the book 354, 392 as acrylic additives. Right-hand side, again, the solvent-free specialists. We have the book 329. And a second recommendation, 327 or 333. And we have the 3560 as our acrylate macromere. When we talk about high solid specialists, we have 320, which gives you a perfect leveling and also has a slight deforming tendency. We have the 3550. And we have our polymeric leveling additive, the book 399. And this small chart helps you to select in the first step the right silicone or leveling additive. Coming now to our last chapter for today's presentation, our rheology modifier. Also here, there's of course a question how to select the right rheology modifier. What do we have to consider when we want to choose the right one? At first, of course, we have to think about the rheology effect. Do I need Newtonian flow behavior, solid plastic or thixotropic one? What is the shear range of my application? Do I only need something for anti-settling, for storage stability? So that means, do I talk about low shear, about medium shear, or about high shear when I need something for high shear applications? Which possibility of incorporation do I have? Do I have the possibility to add something in post-addition? Do I only have medium shear forces? Maybe I have high shear forces? Or do I need a premix or an intermedio? What are the side effects? Maybe there are also some negative side or undesired side effects. For example, rheology modifier may have an influence on the gloss. They can be influenced by pH value. That is, for our today's presentation, not really important since we do not talk about waterborne coatings. They have an influence or they can improve the color acceptance. And of course, also here we have to think about regulations. When we have a closer look at the book portfolio, we have for all kinds of systems products. We have products for waterborne as well as for solvent-borne. We have solid products in powder form, but of course we have also liquid ones. When we talk about waterborne and solid, we have Optigel, Optibend or Leponite types. Waterborne and liquid, we talk about Rheobuc, different chemistries, polyurea, polyamide, as well as acrylate thickeners, for example. We have Aquatix and we have Leponite. But today I would like to focus, of course, on solvent-borne. Here we have the solid one, Claytone as well as Garamite, and we have the Rheobuc types. Besides these three families, we also have the Ceratix or Cerafac types, which are wax additives with a certain rheological behavior. Let's start with the liquid rheology additives. Here we have, for example, our BUC 410 family. We can use these products for anti-settling of fillers, for sag resistance. We have a strong shear thinning effect. And the good thing about this product is they're easy in handling. And easy to dose. So even an incorporation after the production in post-addition can be done. Here we have again an example, sedimentation of zeolite after 16 days at 40-degree hot box. Left-hand side, you see that you have a small sedimentation. In right-hand side, with using 0.3% of Rheobuc 3410ET, you do not have any sedimentation or syneresis. Now I would like to come to Garamite and Claytone, our additives in powder form. Garamite is our group of mixed mineral technology, and Claytone is one group of our organoclay family. Let's start with the Garamite types. Garamite is a mixture of plates and an organic modification. We can achieve a very strong shear thinning effect and anti-settling properties in case there is anti-settling properties of fillers needed. It is possible to get a higher sagging limit. And it is easy to incorporate. And when we compare it to fumed silica, we don't have such a high dust formation as compared to those ones. In case we want to improve the efficiency even more, we are able to combine it with TIX boosters. Here we have a slide where we compare the behavior of the different products. At first, I would like to show you again a small movie. We have three different rheology additives in powder form. We have an hydrophobic silica, an hydrophilic silica, as well as an Garamite. And when you look very close, you see that the Garamite is much easier and faster to incorporate in liquid resins as compared to the silica types. We get a very nice and well distributed rheology modifier in my liquid resin. What is the main behavior of Garamite? We achieve a pseudoplastic flow behavior. We have a fast structure recovery, so that means we can achieve a good sagging. And we have a strong shear thinning effect that leads to a low application viscosity. But we also would like to highlight the perfect anti-settling properties in polyurethane application. Here in that case, we have two co-grinds, one brown one and a gray one. It was filled in glass jars and we stored it for 7 weeks at room temperature. And you see, without rheology modifier, a strong sedimentation. With fumed silica, you have a slight one, and with using 2 of our Garamite types, you do not have any syneresis or sedimentation. Another example was here the light gray one, after 4 months at room temperature, without rheology modifier, and even so when you're using a fumed silica, you have a very strong sedimentation, settlement or sedimentation of the different pigments. When you use two different types of garamite, here in that case it was used garamite 3705 and 2578, you only have traces what you can stir up very easily. To summarize, it can be said it is an excellent anti-settling agent for solvent-borne systems, for co-grinds like you see here, but we also can say that you can use it for pigment concentrates. It has no impact on gloss of lower film thickness systems, and it provides a stronger anti-settling effect compared to standard fumed silica. That is what you see here, very obvious. And it provides excellent application properties and very good storage stability. Let's come now to the Claytone, or our organic modified natural clays. Also, these products provide a significant improvement of anti-sagging in our coating. They give a good anti-settling, and they help to improve our storage stability. We can add these products as powder form during the pigment grind, especially when we talk about high film build systems. And you can prepare a pre-gel for lower film thickness systems and for high gloss systems, so that you do not have any bad incorporation or any influence of the gloss. So we differentiate three main types of Claytone. We have the standard clay, like for example Claytone VZ or 40. We have the self-activation clay types like Claytone APA or AF. And you see already here on the platelets, there's the amount of the organic modification higher as compared to the standard one. And we have the maximum performance clay. In order to achieve a maximum performance, we have a special processing which increases the amount of organoclay platelets which are made for the quatinization even more. Having a look at our product overview. In general, as mentioned, we differentiate between conventional and between self-activating. We can say that it has an influence on the incorporation. So Claytone 40 is not so easy to incorporate as, for example, Claytone AF, which is self-activating and therewith easier to incorporate. And also here we can list them according to the polarity of our system. Depending what is used, you can use different of these types. I would like to show you now some examples in application. In that case, it was not used in high solid systems, but we used a 2 kPu based system, which was based on Macronal SM510. The dosage of our rheology modifier was 0.5% on total formulation, and it was done with a pre-gel, so it was not incorporated the powder, but the pre-gel. And what we can say here is that Claytone 40 gave us the best compromise between increased sag resistance and more or less no influence on haze. What do we see here? So it means the light blue is a haze, the dark blue is a gloss at the 20-degree angle, and the orange column is a sagging limit. And you see that these three types, like the Claytone HY, AF, or HD, has in this system a higher sagging resistance, but we have to say that we have a strong influence on the haze. So that was the reason why we said, okay, the best compromise was a Claytone 40. All other three products are also very good products, but that is what you have to check when you use it in your system. You see it also here on this picture. We have again the reflection of a light, we have two panels, one with a Claytone 40 with 0.5%, with Claytone HY, and you see that the image of the light is with using Clay 40 is much sharper. So we have less influence on the haze with using Claytone 40. We also have here a recommendation chart for sag resistance. We will focus on that left-hand side. That is our selection chart for GI systems, especially when we talk about 2-pack PU systems. We always recommend to start with Claytone 40. It has the lowest impact on haze. And then depending on your results or your system polarity, you can go, when you have a higher polarity, you can go to Claytone HT. And if you want to have an easier to incorporate version, you can use the self-activating type. It is a Claytone HY. When you have good results with Claytone 40, but you want to have an easier to incorporate version, just go to Claytone AF. And also here, when you have a higher polar system, you can switch to Claytone HY. So with these 4 products, you can work in your 2K PU systems. We talk about epoxy systems, it's a little bit different. Here our recommendation is VZ, MPZ or APA. Coming now to a special group in our rheology portfolio, the TICS boosters. What is the benefit of TICS boosters? So these boosters work only in combination with modified, for example, with Garamide 7305 or with silicas. And these additives, these boosters, are able to strengthen the 3-dimensional network. Like you can see here, it builds a connection between the fumed silica and garamide. And therewith, it brings a significant increase in viscosity. So we can say it boosts the efficiency of our solid rheology additives. It can replace hydrophobic by hydrophilic fumed silica. It is easy to incorporate, and we are able to improve the storage stability of hydrophilic fumed silica. Coming now to some application results. Here we have 2 applications. We have here an hydrophobic fumed silica, 1.7% in the system. And without TICS booster, we achieve 600 microns. When we have an hydrophilic fumed silica and we combine it with a TICS booster, our sag resistance is increasing significantly. Additionally, we can say with our garamide in combination with the TICS booster, here in that case with Rheobook R605, we have less viscosity drift over time as compared to a fumed silica. That is what you see here on this slide. Left-hand side, we have a system with 2% fumed silica, measured after 1 month, after 1 day, 1 week, 2 weeks, and 1 month. And you see that the viscosity, that there is given a certain viscosity drift. When we do the same with garamide, with 1% garamide, and with 10% Rheobook R605 on top of the garamide, you see that the curves are closer together. So that is what I mentioned. With using garamide in combination with the TICS booster, the drift of viscosity over time is less. So that leads me to the last selection chart for high solid and solvent-free PU systems. When we talk about Claytone, I mentioned that we always start with Claytone 40. We have garamide 7305 and our liquid thixotropes, Rheobook 7410Ca. Going to the solvent-free specialist, we have the Rheobook 405 ReoBook 7410ET. We can highlight as second recommendation the Geromite 1958 or ReoBook D410. And going to the high solid specialists, we have Claytone AF HT, as well as the ReoBook 7405, which is a TIX booster. So, as summary, we can say after now this 75 minutes lecture, we went through all 4 chapters, through all 4 product groups, and now you have a product selection what you can use for your high solid system, for your solvent-free system, or in general for your 2KPU system. Thank you very much for your attention.
Yeah, thank you very much, Karina. It was really a very, very interesting presentation. And I think also our customers enjoyed